All right, Stephen. We had one more company who presented at Hot Chips. We talked about Intel, we talked about ARM, but now it's time for AMD. They provided a glimpse into the upcoming Siena family of Epyc processors that have been tailored for edge computing. These processors are designed to offer up to 64 cores and 6 memory channels, focusing on power efficiency in a smaller form factor. Siena is projected to have power consumption ranging from about 70 watts up to about 225 watts. That's a significant reduction compared to the other AMD silicon configurations. The specific Zen Core variant, which would be Zen 4 or Zen 4C, being utilized in Siena hasn't been confirmed yet, but the chips are expected to ship later this year, and they are targeted at edge computing market demands. So even edge is something that's near and dear to your heart. What's AMD hoping to accomplish with this?
Well, so Bergamo is AMD's offering for basically maximum core density in typically in cloud data centers. In other words, the current offering has 128 cores or 256 threads per socket, and man, that is a lot of processing power. But it may be too much for a lot of applications. So Siena is basically a scaled down offering. Now, again, we don't have a lot of details, but I'm going to go out on a limb here and guess that these are probably the compact Zen 4C cores that you find in Bergamo. In other words, these guys, AMD stripped out some of the supporting functions. They trimmed the wafers and kind of crammed things in as much as they could. But these are still full Zen 4 cores with the full Zen 4 instruction set. And this allows people to basically run at almost full speed any application that'll run on Zen 4 in a more compact form factor. And that's really what this is all about. So I expect to see Siena gaining ground, as we said, in edge devices, meaning smaller compute devices that are going to be deployed in the telco, 5G, maybe at the premises and industrial IoT kind of locations. I also expect Siena to find some ground in embedded network devices. And I think this is something you might be interested in, Tom, because basically this is the latest and greatest x86 platform from AMD, and in a smaller, lower power form factor. I think that we could see this almost as a competitor for the famed Intel Xeon D, which is Intel's similar lower powered, more integrated, less cores, but still a Xeon and still supporting all that good stuff. I think that Siena is basically AMD's Xeon D, and I think that we're going to see it in storage, in networking, in security devices. What do you think, Tom?
I think you're right. And that was one of the things that Intel really hit on when they developed Xeon D, was realizing that appliances don't need a lot of compute power. In fact, they work better when they don't have a lot of compute power, because you never want stuff being offloaded to the CPU for that work to happen. It just slows everything down. That's why ASICs have been so big for so long. And AMD is going down the FPGA route with their Xilinx acquisition, and they're really heavily investing in DPUs to do some of that offload stuff. But I think that if you want to have a holistic solution in a system that runs AMD DPUs, you've got to have a processor that's matched to that. You don't need something that's power hungry and going to chew up a lot of space in the system. You just need something to be able to run the management plane. And I think that that's where Siena really fits in nicely. Is I need a watchdog, basically, like a substitute teacher. I'm just here to make sure that nothing bad happens. But other than that, just do your thing. And by creating a low power option, but still supporting all of the other, Zen 4 instruction sets, you're basically saying, we're not going to run these things flat out. We just need them to kind of run the system. And then you can start building these, boxes on top of an entire AMD IP, which means you don't have to go look for somebody else to provide that, because it wouldn't have made sense to stick a big Zen 4 into one of these machines. So people might have been like, well, okay, well, they're kind of compatible, so maybe I can go with a lower power Intel chip and use AMD for my DPUs and things like that. And that is a huge boon for edge computing devices, because when you want to start deploying those things to the edge to do edge compute, edge networking, and all that other stuff, you want them to be self-contained, rock solid, but you also want to have your development team be able to program to that chipset and have something that is consistent inside of that, so that you're not, oh, well, crap, we can't use that instruction because this doesn't support it. And what if it has to fail back here? So I'm happy to see that AMD has kind of gotten the memo that you don't just build bigger, faster, you build purpose driven stuff for all kinds of places where you want your chips to be deployed.